So in this video we will see about tree traversal. So here tree means binary tree. So tree traversal, it is a technique to visit all the nodes in the tree. So there are three methods the nodes in the tree can be visited. So that is Inorder, Preorder and Postorder. So in order, in these three, the words in, pre, post, they are associated with how or when the root node is visited related to its left and right child. So in which order the root node is actually visited. So in the in order, the root node is visited in between left child and right child. And pre-order, the root node is visited prior to its left and right child. So in the post order, the root node is visited after the left child and right child are visited. So the actual ordering is in order. First, the left child should be visited, and then the root node should be visited, so, and then right child. Sorry. So left, then root, then right. So in the pre-order, so root node, and then left child, and then right child. So in the post order, left child, right child, and then the root node. So here we will see one simple example for this tree traversal. So here this is a binary tree. So binary tree, each node can have at most two children, one left children and then right children. So first we will see how that in order can be visited. So in the in order, as I already told you, so the root node should be visited in between left and right child. So first we start from the root 1. So where the root 1 should not be visited. Next we need to check whether the root contains left child. Because so in a traditional method, first left child should be visited. So the left child of that root 1 is 2. So now we move to the node 2. So now we need to check. Now the root node, current root node is node 2, and we check whether the node 2 has any left child. Yes, root node 2 also has one left child. So the current node pointer should be moved to the next node 4. So now the current node points to node 4. So now we need to do that in order for this root node. We check whether the current root 4 contains any left child. No. So that means the left child is null. So no left child. So after left child, next the root should be visited. So the current root is 4. So now 4 is visited. So once the root 4 is visited, next we need to check whether that current root has any right child. So now 4 doesn't have any right child. So that current root 4 has been completely visited. So we need to move to the parent of this node 4. So now the pointer will move to 2. So already the left child of root 2 has been visited. 4 is visited. So as per the in order strategy, now we need to visit 2. So and then we check whether 2 has any right child. So don't have any right child. So no need to visit any node. So now the subtree with root 2 2, which the root node as 2 has been fully visited. So now we backtrack to the previous parent of this current root 2. So parent of this current root is 1, and the left child of that one, that is 2, is already visited. So now we can visit 1. So after visiting 1, now we need to move to the right child of 1. So now the right child of 1 is 3. So and then now the current root node is 3. We need to check whether this current root contains any left child. Yes, the current root contains left child, that is node 5. Now the current root moves to 5. So then we need to repeat the same process. We need to check whether 5 contains any left child. No, 5 doesn't contains any left child. So no left child to visit. So we can visit this current root 5. Once the current root is visited, now we need to check whether the current root contains any right child. So now node 5 don't have any right child. So no node to visit. So now we need to move back to the parent of this 5, that is 3. So now the left child of 3 has been visited. So now we can make that node 3 as visited. So once the node is visited, then we need to go to the right child of that node. Now the right tree has one right child, that is 6. So now the current root is 6. Now we need to check whether 6 has any left child. So in this example, 6 don't have any left child. So no node to visit. Then there is no left child, so we need to visit the current root 6. So once the current root is visited, next we need to go check whether it has any right child. Yes, 6 has one right child, 7. So now we need to make this 7 as the current root. Now repeat the same in order for this root 7. So 7, we need to check whether 7 has any left child. No, 7 don't have any left child. So no node to visit, so we can visit 7. Sorry. So we can visit 7. Now once the 7 is visited, we need to check whether 7 has right child. No, 7 don't have any right child. So and then we move to the parent of this 7, and parent of the 7 is 6, but 6 is already visited. So the entire tree has been visited. So this is Inorder tree traversal. So the root node should be visited in between left child and right child. Start from the root of the tree. We need to start this traversal. So whenever we take one node as a root, we need to check whether it contains left child. If it has left child, and then we need to move the root pointer to the left child. If we don't, and then once the left child has been visited, then the root, we need to make a root as visited. So once the root is visited, then we need to check whether the root contains the current root contains any right child. If it is a right child, then we need to traverse through the right subtree. Once the right subtree has been visited, then we move to back to the parent of the current root. So in this way we need to do our traverse. So now how it can be implemented, that means the pseudocode of this Inorder traversal. So the simplest method for any tree traversal is by using recursive function call. So the recursive function call of this Inorder, so this is the implementation of Inorder tree traversal using recursive function. When the Inorder function is called with one root node, it checks whether that current root node is null. If it is not null, so then it immediately call the same Inorder function with its left child as a root. So and then this recursive function called ends. When the entire left subtree is visited, now the node will be printed. Once the node is printed, again it calls a recursive function call with its right child. Then when this entire right subtree has been visited, then this Inorder function call will over. So this recursive function call, when this recursive function call will ends mean if the current root node becomes null. So this is the recursive implementation of Inorder tree traversal. So I will explain this with one simple example. So take this simple binary tree which contains only three nodes. One is a root node and its child, left child is 2 and right child is 3. So for the understanding purpose, the 2 and 3 actually don't have any child node. 2 and for your better understanding, I just take the left child and right child of both 2 and 3 as null. So as per this Inorder function call, first the Inorder function will be called with the node 1. So this initially the Inorder function is called with node 1. Then it check whether this node is null. No, the current node value is not null 1. So it will enter into this true part. First it will call Inorder of the left child of the current node. So here the left child of the current root is 2. So this Inorder 2, that recursive function will call. Now the same Inorder function is called with node 2. Then again it check whether the current node is null. No, the current node is not null. This is 2. So inside this true part, first it call Inorder of left child of the current node 2. So current node 2 don't have any child. That means the left child is null. So it called Inorder of null. So once Inorder of null is called, it will check the node is equal to null. Yes, the node is null. So this function call will ends. So once the recursive function call ends, then the control will automatically move to its previous function. That means function which calls this recursive function. So the Inorder of null, this function is called by the function Inorder of 2. Now control goes to Inorder of 2. So inside that Inorder of 2, already the Inorder of node left child has been completed. So the next statement is print node. Now the value of the node 2 is printed. So after that, the next statement is Inorder of node of right. Then the current node value is 2. So it will go and check whether 2 has any right child. So 2 don't have any right child. So it will call Inorder of null. Now the node value is null. So this if statement will become false. So this function call ends. Once this function call ends, then again the control will move back to the function which calls this recursive function. So it will go to Inorder of 2. So Inorder of 2 entire statements are executed. So this Inorder of 2 function call is also completed. Once the Inorder of 2 function call completes, then the control moves back to the calling function Inorder of 1. So inside that Inorder of 1, this Inorder of node left, That means this in order of 2, this statement has been completed. So the next statement to be executed is print node. The current value of node is 1, so it will print 1. So after print node, the next statement is in order of node of write. So current node value is 1. It call in order of the right child of node 1. The right child of node 1 is 3. So now we call a function in order of 3. Once this in order of 3 function starts executes, now it check the current node is equal to null. No, the current node value is 3, so 3 is not null. Next, inside that in order of 3, first it calls in order of 3, the left child of 3. Since 3 don't have any left child, so it will call that function with the value null. So once this in order function is called with the value null, it immediately exit completed. So the control moves back to the calling function in order of 3. So the next statement inside that function in order of 3 is print 3. So 3 will be printed. So next statement is in order of right child of 3. 3 don't have any right child, so that function will be called with the value null. Now in order of null is called. So that node value is null, so that function will be immediately exit. So the control will be move back to in order of 3. So in order of 3, now all the statements inside that particular function call is completed. So now this control will be moved back to its calling function, that is in order of 1. So inside that in order of 1 also all the 3 statements has been completed. Now this function is also completed. So now in which order that nodes are printed is first it prints 2, next it prints 1, then it prints 3. So which is the same in order traversal of this binary tree. So this is about in order tree traversal. Next we will see about preorder traversal. So preorder traversal, first the root nodes will be visited and then left child and right child. So for the same example, initially the root node will be 1. In the preorder, the root nodes should be first visited. So we need to visit 1. Then when the root node is visited, then we need to move to the left child. So current root contains one left child, 2. Now 2 becomes a root node. Now the 2 should be visited. Then 2 is visited. Next we need to move to the left child of 2. So 2 contains one left child, 4. Now 4 is the current root, so 4 should be visited. Now we need to check whether 4 contains any left child. No. Then we need to check whether 4 contains any right child. No. Then we need to move to the parent of that 4. Now 2. So now we need to check whether 4 contains 2 contains any right child. 2 don't have any right child. So we need to move to the parent of these 2, 1. We need to check whether 1 contains any right child. Yes, 3. Now the current root node becomes 3. So we need to visit 3. Once the 3 is visited, we check 3 contains any left child. Yes, 3 contains left child 5. Now the current node is 5. So we visit 5. And we check whether 5 has any left child. No. Then we check whether 5 has any right child. No. Then we move back to the parent of 5, 3. And we check whether 3 has any right child. Because the left child of 3 is already visited. So we check whether 3 has any right child. Yes, 3 has right child 6. Now 6 become the current root. So MAC it is visit 6 is visited. Once the root node 6 is visited, we check whether 6 has any left child. No. Then we check whether 6 has any right child. Yes. So 7. Now max that 7 is a current root and MAC it is visited. And we check whether 7 has any left child. No. 7 has any right child. No. and we move back to the previous node 6. 6 is already visited, and 6 the left child and right child of 6 has been visited. Now the traversal ends. So this is the pre-order traversal of the same tree. So now how this pre-order has been implemented by using the same recursive function means the same kind of function, but with a simple change that in the pre-order before the left child has been visited, the nodes would be printed. So that means this print node, this should be written here. So before that in order of left child, we have to print the current node. So that is the simple modification in the pseudocode recursive function called implementation. First, for each node, so this is since this is pre-order here, this is a pre-order. So whenever we do the pre-order of a particular node, we check whether the node is not null. If the node is not null, first we print that node and then call that recursive function called pre-order of its left. Once the left child is fully explored, then we get to call the pre-order of the right child. So this is the recursive implementation of the pre-order traversal. So next, the same way we can do the same post-order traversal also. So in the post-order traversal, first left child is visited, then right child is visited. After that only root node should be visited. So initially one is the root node. Now we should not visit that root node. So we check one contains any left child. So one contains left child 2, and now the current root is 2. And check whether 2 has any left child. Yes, 2 has left child 4. Now the current root is 4. Then 4 don't have any left child, and we need to check whether 4 has right child. So 4 don't have any right child, so it's both left child and right child has been visited. So in this case it is empty, so no need to print anything. So now we need to print 4. So and then move back to its parent 2. Now the left child of 2 is printed. Then we check whether 2 has any right child. So now 2 don't have any unvisited right child. So now we can print 2. So once the root node 2 is printed, then we move back to its parent 1. Now one left child is visited. We need to check whether 1 has any right child. Yes, 1 has right child, that is 3. Now mark 3 as a current root, and we check 3 has any left child. Yes, 3 has a left child 5. Now current root is 5, and we check whether 5 has any left child. No. Then we check whether 5 has any right child. No. Now the current root 5 can be printed. Then move back to the parent of 5, 3. Now for the current root 3, the left child 5 has been visited, so we need to check its right child. So 3 has right child 6. Now the current root will become 6, and we check whether 6 has any left child. 6 don't have any left child. Then we need to check 6 has any right child. Yes, 6 has right child 7. So now the current root becomes 7, and for 7 we check whether 7 has any left child. No. 7 has any right child. No. Now we can print 7 and move back to, once the right child is printed, move back to the parent 6. Now 6 has been printed, and once the 6 has been printed, move back to its parent 3. Already the left and right child of 3 has been visited, so now 3 can be marked as visited, and move back to its parent 1. Now both the left and right child of 1 has been visited, so now we can visit 1. So this is the post order. First visit the left child, and then visit right child, If both left child and right child of the node is visited, then only that node can be visited. So this is post order. Now, what is the implementation of this post order? This is also very simple, the same procedure only with small modifications. So post order of node, first we need to do the same post order. So first post order of left child. So node dot left, then next we should not visit. Next we need to do post order of right child. So node right. Once both left and right nodes are fully visited, then only we need to print this current node. So this is the implementation of post order. Thank you.